Hello everybody, this is Rudra Pradhan here. Welcome to BMD lecture series. Today we will continue with prescriptive analytics and that too coverage on goal programming. So, in the last couple of lectures we have already discussed linear programming concept and we have discussed various types of problems, various types of techniques, various kind of requirements. In the last couple of lectures, we have discussed a concept called as integer programming, which is a specialized case under the linear programming problem, where we look for the optimal solution corresponding to a business problem, where the values of the decision variable will be integer type. And we have also discussed a particular case where we look for the optimal solution corresponding to a business problem, and again we look for integer type solutions, and that too again within the umbrella of binary numbers, that is 0 1. So, that is why the concept was 0 1 integer programming. So, the idea behind this particular discussion is like we are highlighting various special issues depending upon the particular business requirement or problem requirement. In fact, we have discussed these problems in a solver package, and before we start the goal programming, let me take you to the kind of structure where we have discussed the concept called as integer programming. So, in the case of integer programming, we have solved the kind of requirement here, and let us start with a simple problem here. So, we have a simple problem, and where we have two decision variables x 1 and x 2, and then we have a profit function corresponding to x 1 and x 2, that is 7 for x 1 and 9 for x 2. As a result, profit function will be maximizing z equal to 7 x 1 plus 9 x 2 and subject to two constraints, minus 1 is for x 1 and 3 for x 2. So, as a result, the first constraint will be a minus 1 plus 3 x 2, and that limit is here 6, that is less than equal to 6, that is the maximum resource availability, and again second constraint is 7 x 1 and x 2 less than equal to 35, that is the resource availability. And we have already solved here the typical case, and this is typical the solution, which is nothing but actually called as integer type solution. So, that means the problem which we have solved earlier is a integer type of solution. So, you see here we in the specific case here. So, this is the target of objective functions, that means typically. So, this is the objective function target, and this is the target of decision variables, and this is the target of constraints, and which we have already actually highlighted corresponding to this problem. And after the solutions without specific kind of requirement. So, we have x 1 equal to 1 and x 2 equal to 2, that too we have reached the optimality, and the we have received the values of the decision variables. However, the values of the decision variable are integer, but they are not in a kind of 0 1 integer type. So, we have a special case again. So, that means technically if you go to this particular add-ons, so if you put the kind of add-ons here, so you will find there is a restriction. So, now what will you do? So, the restriction will be with respect to x 1 x 2, because that is our decision variables, and the typical restriction about the integer or the kind of 0 1 integer, it is strictly with respect to values of the decision variable. So, that is why. So, in the solver package, after putting all the entries with respect to objective function, constraints, that the kind of limit, this inequality, equality constraint. So, after setting all these things, so the last option we have to put in the solver is the kind of integer type of requirement, and again if there is need of 0 1 kind of integer type. So, again you have to put the we have to put that particular restriction again. So, that means till now we have put the integer type requirement. So, now we will put the requirement of binary type. So, here you will find in the solver mechanism. So, we have a option bin. So, that by default will take you to the the solution which is in is a kind of 0 1 structure, that is the binary structure, the way we have discussed in the last class, corresponding to 4 different variables, where we have a 16 different cases, and out of which a particular case to be finally fixed, and that will help you to address the business problem as per the particular requirement. After putting the add-on, so put the OK. So, now the screen will be appear like this, and then by default, so you can say this is all different case, this is extra kind of options which you can also delete. So, now this is actually the kind of requirement. So, that means what we have done till now. So, the requirement is here. So, the the kind of what we can say. So, this is the restrictions, and this is the constant 1, constants 2, and this is the binary requirement, and this is how the decision variables entry. So, now after putting or setting all these things, so what will you do? You just ask this solver to run the model. So, now here you will find so solutions, and x 1 is 1 and x 2 equal to 1, and that too. So, we will find the value of the decision variable will be actually 16. So, that means see here. So, now the first option here, the first option is here. So, now optimize. So, the question this is okay. Okay. So, now see here. So, what will it do? So, that means we have a 3 options. This original problem, where we have a z value x 1 and x 2, and then we have a integer type solutions, where we have a z value, x 1 value and x 2 value, and again we have a 0 1 integer type solutions, where we have a z value, we have x 1 value, and we have x 2 value. So, now we can have a more comparative kind of situations. So, you see here corresponding to since with respect to 2 variables x 1 and x 2. So, altogether there are 4 different cases 0 0 0 1 1 0 and 1 1. So, so the solver gives the highest ones corresponding to the optimized value of the z, and which satisfy all the conditions. Now, here in the case of z, so it is coming actually 16. So, that will be 16 here, and x 1 equal to 1, x 2 equal to 1. So, now again so what will you do? You go to the package, and again so what will you do? So, we like to solve the problem. So, now you remove this particular this is the this is what the requirement. So, what if you remove the binary requirement, then that means you put the delete options. So, if you put the delete option, then binary restriction will be removed. So, now it is removed. So, now you put ask the solver to give the solution. So, now now putting this particular structure. So, okay. So, solve this case. Okay. So, now this is coming actually here original solution. So, where z equal to 63. So, here z equal to 63 and x 1 equal to 4.5 and x 2 equal to 3.5. So, this is what the original solution, this is what 0 1 integer type solution, and again so go to the solver, again go to the solver and look for the solutions, and that too integer types. So, for that again we have to add a restriction. So, that means we have to go to add options, and then you choose the values of the decision variable, that is here x 1 and x 2, and now you put instead of a binary, you put the integer type requirement, then you put OK, and then ask the solver to give the solutions. So, now here the solution is z equal to 55, z equal to 55 and x 1 equal to 4 and x 2 equal to 3. So, this is what the integer type solution. So, that means now you will find there are 3 different situations altogether. Corresponding to original problem, where optimize z equal z equal to 7 x 1 plus 9 x 2 subject to minus x 1 plus 3 x 2 less than equal to 6 and then 7 x 1 plus x 2 less than equal to 35. So, the original solution is z equal to 63, x 1 equal to 4.5 and x 2 equal to 3.5. Now, if you put the integer requirement, then Z will be compromised to 55. That means there is a reduction of profit level here, and where x 1 equal to 4 and x 2 equal to 3. So we have no business about the values of the decision variables, since it is coming integer type. So now if we compare the Z value, it has a decreasing tendency, and again, so now if we put 0 1 integer type solution, so now here Z is coming 16. So now if you will see, originally Z was 63, then 55, now it is come down to 16, and where x 1 equal to 1 and x 2 equal to 1 only. So this is actually very strict in conditions for the kind of business requirement, and then you can apply this particular model if it is highly required for a business scenario or the management structure. Otherwise, applying 0 1 integer programming to have the solutions may reduce your profit level if there is high such requirement in a particular problem. So this is how the results are in front of you. So you can compare and check how is this kind of structure. Yes, they are very interesting and very useful, but it is a very strictly problem specific. So now coming with this kind of discussion. So now what will you do? So we will go to the kind of structure now, where we have another kind of module that is called as goal programming. So corresponding to integer programming, goal programming is also very interesting, and it is also problem specific, and it is a target oriented game. And we start with the simple structure of goal programming. It is not highly different from the items which we have discussed in the context of linear programming, and it is somehow another kind of conditions or kind of restriction which will impose while solving the kind of business problem. So means we start with a simple linear programming, then one after another we are discussing different kind of cases or the kind of special cases through which you can revisit the business problems, and then look for the solution, optimal solutions as per the business requirement and as per the requirement of the management decision. So now in the simple structure or simple understanding, goal programming, it is a variation of linear programming that allows multiple objectives, and that is what goals, soft goals constraints, or the combination of soft and hard, that is non goal constraints that can be deviate, allowing for trade offs in achieving satisfying rather than only optimal solutions. So that means it is typically multi objective kind of structures. Earlier we have discussed couple of problems, and that to couple of business problem corresponding to a single objective with multiple constraints, and that to bivariate structure and multivariate structure. But here it is a kind of very specialized case, and where we have a multiple objectives, right, and that too we have to fix the goals, and then we look for the optimal solution which can address the business problem more accurately, more effectively, and more efficiently. So that means it is a very target oriented games or target oriented business, and for future requirement, for that is how analytics plays a very key role, and that too in the prescriptive kind of analytics. So we typically have a kind of future requirement, and that is how the goal programming has a kind of beautiful structure through which you can through which we can get some kind of output that will address the business problem more effectively as per the future requirement or the as per the kind of present requirement. So goal programming models are similar to linear programming models. In that case, both are formulated under the same requirement and same assumptions, that is the linearity, non-negativity, and certainty, and the kind of typical restriction. And goal programming uses like linear programming graphical method to highlight the particular concept. So that means you see whatever problems we have discussed, whether it is a simple linear programming or it is a kind of integer type programming, or it is a kind of goal programming. So in the same times we can use actually either graphical structure or simplex structure to look for the optimal solution, and that means technically So, graphical methods and simplex methods, that is the primal simplex or dual simplex, these are the typical tools through which you can actually look for the optimal solution corresponding to a business problem, and that too we like to choose the technique depending upon the type of problems like bivariate and multivariate, and then the kind of constraints and the kind of requirement. If the constraints having say supportive to the simplex simplex mechanism, simple simplex mechanism, you can apply the simple simplex mechanism, or else if the constraints are supporting the dual simplex process, then you can apply dual simplex methods to look for the optimal solution. And that means these are all various options with you to solve a particular business problem as per the particular management requirement. So, that means whatever special cases and different issues we are addressing. So, goal programming is also a typical case through which you can actually highlight some of the business problem more effectively, and that too with a future requirement with more vision kind of scenario. So, that means it is basically long term basis, this particular tool will be very effective to address the business effectively. And so far as goal programming models are concerned, so we have strictly the following requirements. So, first requirement is we must have multiple objectives and satisfy rather than optimize. So, that means we are not every time looking for the optimal solutions, but every times we are looking for optimal solution, that is the first hand requirement, but in the same times with respect to business requirement or the kind of management requirement or the kind of societal requirement, we have to do lots of compromise. That is why the specific technique or specialized technique like integer programming, goal programming are very effective tools to bring the optimal solution as per the business requirement, as per the kind of societal requirement. So, here the our issue is to minimize underachievement of goals, and that means technically we have actually discussed several issues in the kind of predictive analytics. In the predictive analytics, what we have discussed, there are three different types of models or three different types of scenarios. So, the first one is called as exactly identify models, and if not, then we have two different options. One is called as a under identified model, another is called as over identified models. So, that means so this is like confidence interval. So, corresponding to a particular objective. So, if it is exactly fitted as per the objective constraints, conditions, requirement, specific goals or something like that. So, then this particular structure or this particular model is called as exactly identified model, and if not, then we have little bit plus minus, that is what the confidence interval, and the top one is called as over identified case, and the bottom one is called as under identified case. So, in the linear programming problem corresponding to predictive analytics, so we have the typical strictly optimizing output. Then corresponding to strictly optimizing output, we have over kind of achievement goals and under achievement of goals. So, in the goal programming, so we have two different approaches to address the problems as per the business requirement or look for the solution as per the business requirement, setting more number of goals corresponding to a particular models, that too with given resources, with given the requirement of revenue, profit and something like that, and then we look for the optimal solutions. So, there are two approaches to solve the goal programming, like in the case of integer programming, we have already discussed cutting plane mechanism and branch and bound mechanism. So, the first approach in the goal programming to look for the optimal solutions to achieve the particular target or the goal. So, that is the weighted models and then the rank based models. So, we have to assign first of all we must have more number of objectives, that is typically called as multi criterion decision making process. So, multi criterion decision making process means all these models which is nothing but helpful for decision making process. That is why management decision is very effective in this kind of scenario. When we look for the optimal solutions and getting the optimal solution as per the business requirement, then management decision by default will be very effective. but here there are scenarios where we have a multiple objectives. So, when there are multiple objectives, then some complexity by default will be there. For instance, if it is a single objectives, so there is no point to compromise anything. Okay. So, of course, the kind of integer or 0 1 integer, these are all specific requirement, business requirement, but it is not the kind of target or goal specific kind of approach. But in real life scenario, having big business or dealing with big problems, so then there are more number of objectives simultaneously. So, it is not just to achieve a single target or single objective, you have multiple target and multiple objectives. So, when your business is very big, then by default goals and objectives will be also very high. So, when you have more number, like what we have discussed, with a single objective, if you have a more number of constants and condition, you will find the kind of optimality and the value of the objective function strictly restricting accordingly, means according to the restriction and condition and what the way we are imposing. That is what we have already highlighted, the original problem, the optimal solution, the solution with respect to integer type, then solution with respect to 0 1 integer type. So, now here the special cases since corresponding to a particular model case with respect to 2 variables or more than 2 variables. So, now we are adding another or few more constants corresponding to the objective functions. So, that means we have multiple objectives and multiple targets, and in that case, so the complexity of the problem will be more high, and then within the complexity, within the kind of business requirement, with the kind of business conditions, again so we look for the optimal solution. And so, the first one is the weighted model. So, here we have to first identify the number of objective or specify number of objectives, and every objective can be connected with a particular weight. So, we have two different mechanisms altogether, equal weightage principles and unequal weightage principles. In fact, if you say equal weightage principle, then then you go by simply actually simple approach, but when you will go for unweighted kind of approach. So, where let us say there are 3 objectives. So, ultimately how much weightage you will give into first objective, how much weightage you will give into second objective, and so on. So, assigning weight is a very typical issue, and so that is that you have to derive properly and then fix before you start the particular process. Then another is rank based approach. So, you have to assign the rank, then start the process valuation. So, likewise you will find. So, for example, we start with a simple example here. So, here so there are 3 what will you call as 3 constants, the constant 1, constant 2, constant 3, and this is the objective functions, and that too we have 3 variables. So, this is first variable, second variable and third variable, and corresponding this is a first constant, second constant and third constants, and these are all restrictions corresponding to all these constants, and these are all objective functions value. That means the objective function will be maximize z equal to 70 x 1 plus 110 x 2 and 110 x 3 subject to 4 x 1 plus 3 x 2 plus 7 x 1 less than equal to 9000, and then 2 x 1 plus 4 x 2 plus 3 x 3 less than equal to 6000, and 2 x 1 plus 3 x 2 plus 4 x 3 less than equal to 5200. So, this is how the simple models means see whatever we have discussed so we always start with simple, then we are putting restriction one after another. So, that means you just imagine simple linear programming, then the kind of cases, special cases, the way we are discussing. So, you will find very interesting, and that too that is how the prescriptive analytics is very interesting while addressing the business problem as per the particular business requirements. Now, to transfer this particular case into model, so we will have what I have already mentioned. So, this is how the objective functions, and these are the 3 conditions, and this is how the non-negativity restrictions. So, this is how we have transfer the particular information into a model format, and we like to now optimize this model, and since it is linear programming and all are linearly related. So, you can easily actually start the process, but the complexity will complexity will start when we connect with different objectives. So, now in this particular problems, so three variables with the 3 constraints. So, we are actually fixing here 4 different goals. So, the first, that is why it is called as goal programming. So, we must have different goals, then we will look for the goal programming. So, it is again very specialized kind of situations, and that to to address the business problem. So, the first goal is with respect to objective function, achieve total sales of at least 1,80,000, and then the second goal is to achieve the exterior door sales of at least 70,000, then interior doors achieve of interior door sales of at least 60,000, then the commercial door sales is at least 35,000. So, all these are actually with respect to decision variables only, that means strictly towards the objective functions. So, because the objective function is x 1, x 2 and x 3. So, that is with respect to exterior x 1, interior x 2 and commercial x 3, and in total it is called as total sales, that means x 1 plus x 2 plus x 3. So, this is how 4 goals simultaneously are there corresponding to our original problem. So, our original problem is here, this one is our original problem. Now, we have a 3 different specification corresponding to these 3 different specification, we specifying 4 different goals. So, as a result, this is additional kind of targets or the kind of conditions we are imposing to a problem while highlighting the business issue or dealing with business problem. So, now as a result you have to refresh the particular structure. This is again a similar kind of sensitivity structure, where we are putting more restriction, more kind of conditions, again look for the optimal solution as per the particular business requirement. So, now to set the business goal programming. So, that means the goal programming requirement is the original problem structures and the targets, that is the goals, and now the original problems and the goals which we can combine, then design a new models, and that models by default will be represented as a goal programming model, and then look for the optimal solutions which can address the business problem as per the particular requirement. So, now to design the goal programming corresponding to all these 4 objectives. So, what I have mentioned earlier. So, we have a particular objectives, then by default for every objectives we have underachieve and overachieves, like over identify models and under identify model. So, that is how. So, we have actually 4 different targets, goal 1, goal 2, goal 3, that 2 with total sales, then with respect to x 1, with respect to x 2 and with respect to x 3. So, what will we do? So, we define or we fix a kind of structure here, dt minus, that is the amount which by which the total total sales goal is underachieved, then dt plus, that is amount by which total assets goal of will be overachieved. So, this is with respect to total sales, and so that means if this is the a particular objective. So, we will go for overachieve like this and underachieve like this. So, this is how the confidence interval will be. So, that is with respect to the first goal, and against the amount by which the exterior door sales goal will be underachieved. So, this is with respect to x 1, and again, so d 1 minus 1, d 1 plus 1. So, this is with respect to x 2, and again d c minus 1, d c plus 1, this is again and the commercial door sales goals is underachieved and overachieves, and this is with respect to x 3. So, that means corresponding to our objective functions. So, now we have actually design a kind of structure or in a such a way that the objective function has some kind of deviations. That is how the goals we have achieved. Means see, we are looking for the optimizations, not only the existing research need to be optimally connected and look for the optimal solution where profit can be optimized or cost can be minimized, and with respect to given resources and given constraints. But in the same times, since it is a kind of business process, so every times we have a kind of targets, we have a we have goals. So, that is how there is a kind of there is a possibility of deviations. So, that means with respect to a specific objective, when you are putting a target and goals, then obviously we have to actually work, or we have to reorient the resources to achieve the particular target. So, while doing this one, so we are putting lots of risks, so we may achieve, we may not achieve. So, as a result, if we achieve, how much average kind of over the particular target, then if not, then it is a kind of underachieve. So, that means there is a little bit deviations corresponding to a particular requirement. So, we like to know if there is a kind of deviation with respect to a particular requirement, then what is the optimality structure altogether. So, that means corresponding to 4 different goals. So, we define 4 different new variables and corresponding to underachieve and overachieve of a particular goals. So, altogether we have now 8 new variables which you can introduce in the setup and then redesign the models. Again, it is a what I mentioned earlier, any condition, any restrictions, whether it is with respect to constants or with respect to variable or with respect to objective function, it is nothing but sensitivity analysis structure. So, now after doing all these things, so we look for the kind of structure. So, now the particular model can be redefined again. So, the particular multiple goals will be like this, corresponding to the total cells. So, the corresponding to the total cells. So, this is what the particular item underachieved and overachieved. So, this will be equal to 1,80,000, and then with respect to the x 1. So, this is with respect to x 1. So, 70, and this is with respect to second, and this is with respect to third. So, as a result, and these are the underachieved and overachieved targets, and with respect to the kind of requirement. So, we have fixed, that means technically these are all 4 different constants now to be added into the process. So, the objective function will be rephrased now. So, now minimize the total underachievement of goals, that is how here dt minus and d minus d 1 minus and di minus and dc minus. So, that means these are all actually underachievement goals. So, we like to minimize the underachievement of goals, so that it will satisfy the business requirement, the conditions and the kind of constraints. Then corresponding to these objective functions, and the kind of constants will be now, the kind of constant will be now like this. So, earlier we have this constant, we have this constant, we have this constants. So, now we have a new objective function now corresponding to this goals, and then so these goals with respect to underachieve and overachieve. So, we have actually 4 different new constants. So, the equality constant that will be added into the process, and then we look for the optimal solution. That means, now the original problem corresponding to this is what the original problem, this is what the original problem. Now, after the targets, after the targets or goals. So, the model is now redesigned, and then the final model will be here minimizing the objective functions is the total underachievement of goals subject to all these restrictions. Corresponding to our original problem, we have 3 restrictions or 3 constraints. So, now we have actually 7 different constraints, and while the objective function is with respect to 4 variables, that to in the earlier case we have 3 variables, that is with respect to E, I and C. So, now let us see how is the kind of structure, and this is how after doing this ones, then we can connect with either weighted kind of models or rank based models. So, now if you go by weighted kind of models, so we are putting actually in the case of goal ones we are putting 5, and in the case of second we are putting 1, third case we are putting 1, and fourth case we are putting 1. So, then the new the typical objective function will be minimize the total under achievement of weighted underachievement of goals. So, that means earlier the kind of structure was so this is what the simple objective function. Now, we like to actually optimize with weighted weighted objective functions, that is weighted under achievement of goals, that to the minimization process. So, just connect the weight with a corresponding variables like here earlier it is here dt, de, di, dc. So, now you have to just connect with weights corresponding to all these variables, right, corresponding to all these variables. Then refresh the particular objective functions. Now, after doing this, so let us see the kind of structure. So, in fact, while doing this weight or rank, your constant structure will not change. So, these are all the constants, only we have to give in the weight to the corresponding objective function and then look for the optimal solution. So, now again you go to the solvers, and then these are the kind of structures through which you can. So, original problem is here 4 3 7 2 4 3 2 3 4, that is with respect to the variables E, I, C, and then these are all actually the kind of targets or goals corresponding to the corresponding to a particular I targets, that means total sales goals, that is 70, 110, 110. So, that means is typically we derive from here only. So, this is what 70, 110, 110, and this by default will be 1 1, and this is what the upper limit. So, just we transpose the derive these variables inputs, then you put in the kind of Excel solvers, and these are the variable indications. This is what the first variable, second variable, third variable, and this is underachieved total sales. That means technically, so this is what the first variable, second variable, third variable, and this is what the original constants, and these are all called as these are all called as later constants with respect to specification of the goals, and these are all the requirements of underachievement and overachievement targets, and then these are the limits with respect to the constants, and then we look for the optimal solution. It is a same process. So, this is what the values of the objective functions, and this is what the targets of the decision variables, and these are all weights, and it is a simple kind of structure again. Then I just operate the process, same things here, like you have objective function here, and this is what the decision variables, and these are all constant, the way we have solved in the case of integer programming. So, that means we can actually solve these the objective initial objective functions and these three constant we can actually solve, and then look for the solutions. Now, that means we have original problems, and then where we have actually E, I, you have to find out E, you have to find out I, and you have to find out C, and then we can look for the optimum value. So, now we have a goal programming here, where we have actually 4 different goals, and then there is a kind of targets, and as a result, so we have again z value, so which is actually appearing here, and corresponding to new objective functions, where we are targeting dt minus, and then d minus, and di minus, and dc minus. So, that means here we like to find out dt minus, that is the underachievement targets, then d minus, di minus, and dc minus. These are the requirement which we would like to report now. So, now with respect to setting, just add on all these constants one after another, and since there is no requirement of integer type of target, then you just put OK, and then you look for the optimal solutions. So, now the typical optimal solution will be like this. So, now this is how the particular structures, and then this is what the solutions, and then that solution will help you to achieve this particular target. Okay. So, that means technically the way we have actually set the goals. So, the results are here. So, that means technically the objective function will be 10,833.33 corresponding to the values of the d means we have actually values for decision variables for all the variables, but our target is only dt minus, and di minus, dc minus, and d minus. So, that we have to actually target, and then we have to find out the objective function value. So, this is how the final output under this objectives, and formulating, that means second task is rank based goals, where the same targets are there, and then we like to actually fix up the model, and then this is what we are putting actually rank 1, rank 2, rank 3, and that to goal 1 goes to rank 1, goal 5 goes to rank 2, and then rank 3 is in the case of goals 2, 3 and 4. So, now the new deviation variable will be ds minus, and then accordingly, so the problem will be against minimize the rank deviation. That means, in the weighted model case, so we like to assign weight to corresponding underachievement targets, and then here in the case of rank base, we are just assigning rank, that is again similar kind of weights, but the rank will be connected with all the decision variables, and the constants are more or less same. So, see here, in the earlier case, here there is a weight factors W1, W2, W3, W4. Now, since we are putting actually 3 ranks corresponding to total sales, then the kind of DS, and then this is a second goals, and then the other goals which we have actually equal ranks. So, as a result, so we have actually 3 different rank requirements corresponding to the particular problems, and that to the given constraints. So, same original constraints, and then we have here the targeted constraints. So, now again you look for the solutions. Now, corresponding to this new objective functions and these constraints. So, we will again go to the kind of solutions. So, the objective function, the first LP model, and minimizing rank 1 deviation dt minus 1. So, that means technically the objective function minus second LP model. So, this is how then there is a additional constant here. Then finally, the objective functions minus third LP and minimize the rank 3 deviations. So, now the total structure will be like this, and then finally, you look for the kind of solutions. The final solution will be like this. So, again it is more or less same like the weighted case. So, these are all actually original variables, and these are all after targeted variables, and this is how the kind of constant setups, and then again this is what the objectives, and this is what the decision variables, and these are all constant. Now, allowed to solver to give the output, then finally, the output will be here. So, these are all actually the kind of targets, and this is how the rank based methods will help you to solve the business problem under the goal programming scenario. So, as usual, so this is what the final the rank 2 goal only, and this is what the kind of rank 3 goals only. So, that means there are different cases altogether, and so this is what actually rank 1 case, and this is what rank 2 case, and this is a rank 3 case, because we have a 3 different ranks. So, that means 3 sets of outputs now, and corresponding to this particular rank assignment, and that too with respect to 5 different 4 different goals. So, we have actually different kind of structure through which we are looking for the optimal solution which can address the business problem more effectively. So, that means typically in this particular structures we have discussed several kind of business problem dealing with various methods, and there are within the particular structures we have discussed various specialized cases, starting with integer programming, 0-1 integer programming, goal programming, and that too within goal programming, weighted based structure, then rank based structures. So, ultimately, so this will give you what we can say that more flexibility and more kind of in depth kind of search process through which you can address the business problem more effectively and look for the optimal solution, the values of the decision variables, the kind of targets to be achieved, and then you may be in a position to address the business problem more effectively, more efficiently, and then come with a kind of management decision as per the particular business requirement. With this we will stop here. Thank you very much. Have a nice day.